Hello, Internet. My name is Peter Reilley, and I'd like to discuss some of my inventions. I'd like to talk about an invention of mine that projects an image onto a screen. This is a novel way of doing it. Back 20 years ago, when I got the patent for this, projection TVs were a thing, and I thought that this might be a way of building a projection TV using a different method than the then current method of just projecting using lenses. The advantage of this is that there is no focus. It never goes out of focus, very similar to a pinhole camera, and it uses the idea behind a pinhole camera for one axis only. But projection TVs are no longer a thing. They were a thing 20 years ago. I have no idea what use there may be for this these days. The patent is expired. I'll show how it works, and you can use it however you like. Here's a demonstration of the lenticular viewing device. I'll turn off the room lights so we get a shot of the projected image. I'll zoom in, okay, and you can see the stick man. Go to the view from the right. You can see he remains. You go to the left, he remains. You move up, you can see he moves off screen. And let's have a look inside the box. And you can see the stick man that we're viewing. In here, you can see the slit that we're projecting. And on the front, I'll zoom out a bit. In the front, this is a piece of lenticular lens plastic sheeting. The lenticular pattern is vertical. It has to be in the same direction as the slit. And I'll take the slit out, and you can see the slit is just a piece of cardboard with two aluminum sheets taped very close together. Nothing really magic about it. The whole thing is just a cardboard box with a stick man as the view, and the lenticular screen generates the image. There is no lens. It has the characteristic of being always in focus, very similar to a pinhole camera, that by moving the slit back and forth, we can change the magnification in actually one direction only, in the horizontal direction. In the vertical direction, the size of the image will remain constant even as we move the slit back and forth. In the horizontal direction, the image will be magnified or shrunk, just like with a pinhole camera. This is a diagram illustrating the method for understanding how the image is created in this optical system. This is something where I noticed the effect, and it took me some time to understand how this could actually work. And this is the explanation that I came up with. This is a diagram representing the elements. This is the object being imaged. This is the slit. This is the lenticular screen with the lenticular elements, the cylindrical lens elements running vertically. They're always parallel with the slit, and this is the object imaged at the lenticular screen. this is the viewer, this is the eyeball of the viewer that will see the image. The explanation that I came up with was to consider the x-axis and the y-axis separately. The x-axis represents the view from the top. So looking down, and in that view, the slit is simply a pinhole, and the lenticular screen acts as the same thing as a ground glass or a translucent screen. So that in this instance, the object is imaged with light, the light rays passing through the slit, impinging on the lenticular screen, and the cylindrical lenses in the lenticular screen spread the light in all directions. This ray passes through and impinges the lenticular screen, and the light is also diverged. Some of these diverged rays will enter the eye, and as such, in the x-axis, the object will be imaged at the lenticular screen, or you could consider it the ground glass in this case. The eye looking here will see an image here. In the y-axis, which is in essence looking at the system straight down, in this axis, the slit is just simply wide open. It has no effect on the optical path. Likewise, the lenticular screen has no effect on the optical path. In this case, the light rays from the object that you're imaging pass straight through the slit, straight through the lenticular screen, and arrive at the viewer's eye. Likewise, this ray. So that in this circumstance, the viewer will see the image at this depth. In this view, the observer will see the image at this depth. This results in an astigmatic display. In other words, it is a image whose focal length is different depending on the axes of the measurement. So even though it appears that the astigmatic effect is quite large, the image is actually nevertheless viewable, as I showed in the demonstration here. So, and this is the explanation that I came up with for why this effect works. This is a patented invention of mine. However, the patent is expired, so anybody can do anything they want with this. It was patented in October 26, 1999, and the patent number is 5971547.